So this book, Cracking the Coding Interview, is constantly emphasizing algorithms. And I find that true. I find that, you know, like even if you're going for a software architect job, as long as you're staying in the software engineering realm, um, algorithms appear to be very central. And the more advanced you are at algorithms, uh, the better you are. So uh, seems that that's central to everything. Uh, so um, at data structures, right? Obviously, you're going to be using Python, and Python with the data structures, using Python on the data structures, and then using the data structures on the algorithms. Um, and then you'll have the algorithms in the architecture, the software architecture. Um, but it seems that the more advanced the algorithms are, the more proficient someone is, mainly at the algorithms. That is really the central point of handling of problem solving for software engineering, and that is constantly emphasized in this book. But that's exactly how it should be too. I agree with that, fully agree. So it's good at the interview, like they're saying, and knowing the algorithms is directly related to the problem-solving skills, which is really what the interviewers are testing you on. But they'll always use the same old problems, so that's why we learn patterns. So common algorithm patterns, that's what's important to solve any new problem. So example here, when you start the interviewer, it's talking about the interviewer here. This is a section talking about the interviewer. They're looking at how you're solving a problem, and they will see, like, are you using an algorithm? If you're not, they will stop you and try to put you on the right track. If you are using a different type of algorithm, like it says right here, if they haven't said anything and there is a fairly obviously brute force, remind them that they can start off with brute force. Their first solution doesn't have to be perfect. So there probably is a lot of problems that can be solved with brute force, but they are not. That's not the way to solve most problems. That's why there are many types of algorithms instead of just brute force. So they'll be looking for that. But if a person is stuck, they can start off with brute force. They don't expect interviewers to be perfect, but they do expect them to have. They do expect to see some competency. They're also looking for conceptual concept, and that means algorithms, concept in algorithms. But they are looking for them to code that. So as long as they can get through, make attempts with some suggestions from the interviewer. So coding algorithms is the main part of this, and that's what the interviewee has to prepare. Passing the interviews, I think, come down to how how advanced of algorithms can you code. In my opinion, the more algorithms you know and the more advanced algorithms you know is a direct correlation to the problem solving, writing code, for the problem solving. That's my opinion. So the structural foundation for the coding, the problem solving, is coding the knowing algorithms, knowing more advanced algorithms, and coding those algorithms. If a person can do that, I think they will have a very strong foundation and be very close to solving any problems, especially advanced problems. And that includes coding hybrid algorithms in the problem solving. And that is, I think, essentially, despite all of this other talk about behavioral questions, and multi-panel, multi-person question, multi-round questions, I think that is most of the issue. And I've seen that it only goes up to middle level complexity, so advanced level complexity, unless you're hitting a specific company, you really only need to worry about middle level complexity algorithms. And that's even for the FANG companies. What a person might also have to look for is, like it says here, specialist questions. If you specialize in Python, that will be your specialist questions. Definitely expect and look for those jobs that are specializing in that, because the interviews will reflect that. That will be looking for that specialist knowledge as a reason to hire someone. The logic being that others can't do it. That's why they need to hire someone to do that. So it's not, in other words, in contrast, it's not reasonable to assume that the interviewer will ask simple questions, because if that were true, then there would be no reason to hire someone. If anyone could do those, because anyone can do those simple things. There's an example right here of that logic. They ask specialist questions to people who aren't specialists. They hire for specialist roles when they don't need specialists. They need specialists but are only assessing pretty basic skills. So there's definitely an emphasis on specialists and testing, interviewing the skills for that specialist. So that should be the interviewee should seek those types of interviews and should expect that interviewing process. Yeah, regardless, algorithms play an important role in this, so we continue on the algorithm, advancing the algorithm knowledge, skills. And in fact, from what I've read so far, up to this point, I believe that one could specialize in algorithms, and they would be the best off in this job market, in the software engineering job market. Algorithms of any time, just make that your habit. Start with the ones that are interviewed, that interviewers use the most, those patterns. The ones that the FANG companies, the algorithms the FANG companies are using the most. And then algorithms in general. Whatever is suggested in the industry. But if you're specializing in a particular language like Python, then algorithms are language independent, but I think the algorithms that you can learn in Python probably the next step down from that, and then general algorithm patterns. So we've got here this, this is talking about freshmen and sophomores and hackathons. So for older people, you have to stay with what you have. If you're not a freshman anymore or sophomore anymore, then you really have to be very good at what you have, what you can't have, which is the algorithms. And let's see, projects, hackathons. Uh, um, yeah, so the projects I think would be how you know, how you use algorithms. Um, hackathons also show, like, present you with different problems and then solving it using algorithms. So it all comes back to that. I would not make projects, or expect to like learn many different. Um, like I would not feature like how many different algorithms I know. I would as a project I would feature as projects how many different types of problems I solved, and that may include that may involve using the same algorithms, but that would be how I would feature projects. Because they care about the efficiency of the problem solving, which can be measured by the big O. So in that sense, they care about the time and space complexity more than they do the variety of algorithms used. And I mean the time and space complexity, the big O, on a variety of problem solving, different types of problems, right? So that's what's important, not the knowledge of many different algorithms, but minimizing the time and space complexity on a wide range of problems. So you only need to know as many algorithms as that is required for that. The reason why I emphasize that is because you make your center point studying algorithms, but I think up to the point where like you're not getting into some kind of you're not just completely immersed in an academic theoretical type of algorithm study, because the real world companies are aware of this this I mean there is that broad range, but it is not it's not used at the real world companies. So it's really the problem solving and the speed of problem solving that is the problem at real world companies. Although there is plenty of academic material on algorithms, so that's the difference to be aware of, pay attention to. So it had a lot to say here, but what I would add to this is that it's very tempting knowing the algorithms that will solve real world problems in a minimized time and space complexity for the business is really tempting for a business. Businesses are very attracted to that, and it's enough that if you can code that in your favorite coding language, those algorithms, it's very tempting to businesses to want to interview. So I think at least a person would get interviews, no problem, if they're really good at coding algorithms, and especially if they're at an intermediate or advanced level, and that will probably remain the central attraction to businesses, and I would bet on that. That's what I would bet on. All of this other stuff like hobbies, making coding projects from hobbies, and so on and so on. It all comes from able to code algorithms, mid-level and advanced, which are applicable to business problems that the business has. But the same algorithms patterns are used to solve different business problems. So once you're in that central area of study, learning those things, then I think that retains the attraction for businesses, and they'll all be attracted to the same thing, and always.